Okay, so we're going to discuss for the another topic, that is riveted and bolted connections and tension members. So we have individual parts or members assembled together compose every structure. These members must be fastened together by means of welding, rivets, or bolts. For the high strength bolts, so these are the examples. For that, we have the high strength bolts have replaced rivets as the means of making now welded structure connections. There are two basic types of high strength bolts used. So we have the ASTM 8325 bolts, and then the other one is ASTM A490. So high strength bolts are usually tightened to develop a specified tensile stress in them, which results in a predictable clamping force on the joint. So therefore, the actual transfer of service load through a joint is due to the friction developed in the pieces being joined. Joints containing high strength bolts are designed either as slip critical or friction type, where high slip resistance at service load is unnecessary. So we have rivets. So installation of rivets requires heating the rivets to a light cherry red color, inserting to a hole, and then applying pressure to the preformed head, while at the same time squeezing the plane end on the rivet of the rivet to form a rounded head. So these are the head, shank, and tail for the rivet. So during this process, the shank of the rivet completely or nearly fills the hole into which it had been inserted upon cooling. So the rivet shrinks, thereby providing a clamping force there. However, the amount of clamping force produced by cooling of the rivet varies from rivet to rivet, and therefore cannot be counted on in design calculation. So the rivets are generally classified as follows. So at hot-driven rivets, so they are the rivets which are driven in hot conditions. For the shop rivets, the rivets which are placed in workshop. So field rivets, the rivets which are placed in the site or field. So cold driven rivets, since the pressure required since high pressure is required to form the head, or at room temperature, this type of rivet is limited. For the riveted connections, so used for very long time, so made of round ductile steel bar called shank. Yan. A head at one end, so the length of the rivet should sufficient to form the second head. So design very similar to bearing type of bolted connections. For the clamp action, so when hot driven rivets are properly cooled down, then the diameter of shank length shank length get reduced. So because of this, the compression of the plate occurs and results in friction between the plates. This process is called clamp action. So disadvantage of riveted connections are as follows. So it is associated with very high level of noise pollution. There is a need to heat the rivet till red hot color. Skilled laborers are necessary to inspect the connections. The cost to remove the poorly installed rivets is very high. So the higher cost installation in the connection. So for the types of riveted joints, so we have the lap joints or overlap joints. So these are the joints which is the members are overlap, or lap joints can be used to join wood, plastic, or metal. So, yun. So we have lap joints or double bolted lap joints, or single bolted lap joints, or eccentricity in lap joints. So for the butt joints, so we have a technique in which two pieces of materials are joined by simply placing their ends together without any special shaping. So on the basis of connecting medium, so we have riveted connections. So the riveted connections are nowadays obsolete because they are understanding of this type of connections for the strength evaluation and rehabilitation for an older structure is essential. While the connection procedure for riveted connections is same as that of bolted connections. So bolted connections, so mostly commonly used connections include the bolted connections. So this connection has the advantage of flexibility in assembling parts of the structure, as well as disassembling it, and in which is necessary if there is inspection or some routine maintenance. So this type of connections is applicable for members subjected to tension or shear, or both tension and shear. So the bolted connections are referred to as concentric connections, so the force transfer in tension and compression members. So eccentric connections in reaction transferring brackets, or moment resisting connections in beam to column connections in frames. So bolted connections can be classified based on geometry and loading conditions into three types, namely shear connections, tension connections, and combined shear and tension connections. So a bolt is a metal pin with a head formed at one end and the shank threaded at the other end, so the nut can be received. Generally, the bolts are used to connect the pieces of metals by inserting them through the holes in the metals. So at the threaded end, nuts should be tightened. So the advantage of bolted connections are as follows. The process of erection of structure can be made faster, so skilled workers are not necessary. Connections do not involve the noise. Requirements of labor is less, so immediate use of structure is possible in case of bolted connections. So alternative arrangement of structural members is possible if required. So lesser working area is required. For the disadvantage, so the material cost is very high due to the area reduction at the roof of the thread due to concentration of stress. So the tensile strength of this type connection is reduced. Bolts get loose if it's subjected to vibrations or shocks. So these are the example of bolted connections. So we have standard size of soles. Slatted holes transfer vertical shear. So horizontal freedom, so permits rotation. So we have the load directions. So we have the single riveted lap joints. So here are the types of riveted joints. So next, so we have the bolted connections in shear and bearing. So we had bolt in single shear. So this one, and then the other one is double shear, bolt in double shear. So for the failure of bolted joints, so we have bolted joint may fail in any of the following 6 ways. So out of which some failures can be checked by adherence to the specification of edge distances or distance. So therefore, they are not of much importance, so whereas the others require due consideration. So we have shear failure of rivet. So the shear stress in the bolt exceeds in the working shear stress in the bolt. So shear stresses are generated because of the plates, or the plates slip due to applied forces. Next, we have the shear plate failure of plates. So the internal pressure of overdriven shank length more than the grip bolts placed at the lesser edge distance than specified causes this failure. So this can be checked by providing a proper edge distance between the center of the hole and this end of the plate, so specified by IS 800. For the tension and tearing failure of plates, so the tensile stress in the plate at the net cross section may exceed the working tensile stress. So tearing failure occurs when bolts are stronger than the plates. For the splitting of plates, so bolts may have been placed at a lesser edge distance than required, causing the plates to split or shear out. Because failure of plates, so the plate may be crushed when the bearing stress in the plate exceeds the working bearing stress. So lastly, we have the bearing failure of bolts. So the bolt is crushed around the half of circumference. So the plate may be strong in bearing, and the heaviest stress plate may press the bolt. So this will be the part 1 of our main lecture. So later on, I will continue the lecture for part 2. So this will be ciao.